All right, so Gemma 4 just hit 1,851 tokens per second on Server's cloud. And I want to know if that actually matters when you stack it up against Gemini 3.6 Flash, because those are two very different bets on how AI should work. Both models dropped recently, and the stakes are real right now. I ran Gemma 4 versus Gemini 3.6 Flash across 4 real tests: inference latency, multimodal reasoning, local deployment, and long context handling. Every number traces back to a verified source, no vendor spin. And honestly, the results surprise me, because the model that looks like the obvious winner on paper might actually cost you more money at scale than the one you'd never expect to pick. I'll get to that. So who is this actually for? If you're a developer deciding whether to self-host or pay per token, this comparison directly affects your monthly bill and your data privacy. Get it wrong, and you're either overpaying for cloud compute you don't need, or you're running into licensing walls right when you want to ship something commercially. That's a real cost, not a theoretical one. Test 1, inference latency. Slow inference isn't just annoying, it breaks agentic pipelines. If your model takes 6 seconds per call and you're chaining 10 steps, you've already burned a minute before the user sees anything. And that's the kind of lag that kills a demo and kills user trust. Speed here is a product decision, not just a spec sheet number. I looked at the published numbers, and here's what we got. Gemma, 431 billion on Cerebras, hits 1,851 tokens per second with a first token latency of about 1.5 seconds, including reasoning, and on an H200 locally Unity test, show roughly 1.5 seconds end-to-end, dropping to about 6 seconds on an L4. What surprised me is that Gemini 3.6 Flash has no published tokens per second figure at all. Now, take this with a grain of salt, because these are completely different infrastructure setups. Gemma 4 on Cerebras wafer scale hardware is not the same as Gemini 3.6 Flash running on Google's cloud. And Gemini's 17% token efficiency gain over its prior version is a cost proxy, not a speed benchmark. So the gap is real, but it's also kind of apples to oranges. Gemma 4 takes test 1. I was expecting Gemini 3.6 Flash to at least put up a number here, and it just didn't. No published tokens per second figure means Gemma 4 wins on the only data that actually exists. So that's 1 for Gemma 4, 0 for Gemini 3.6 Flash. And we're just getting started. Test 2, multimodal reasoning accuracy. Pick the wrong model here, and your pipeline fails on charts, images, or math problems it should handle fine. And you end up with hallucinated outputs on things like financial document parsing or STEM reasoning, which is hard to catch before it ships. Accuracy on these tasks isn't optional. What surprised me here is how different the benchmark sets are. I was expecting a clean head-to-head, and what I found is they're basically running on separate tracks. Gemma 431 billion posts, 85.2% on MMLU Pro, 89.2% on IMA 2026, and 80% on LiveCode Bench, while Gemini 3.6 Flash comes back with 63.9% on MLE Bench and 49% on DeepsWE. Different tests entirely, which is a real caveat. Honestly, calling a winner here would mean making something up. Gemma 4's AIM score jumped from 20.8% on Gemma 3 all the way to 89.2%, which is a huge leap in math reasoning. But Gemini 3.6 Flash's MLE bench result has no Gemma 4 counterpart in the evidence at all. And both models support multimodal inputs without any identical task accuracy comparison that actually exists. This one's a tie, and I think that's the honest call. I went in expecting Gemma 4 to dominate on benchmarks, and it does on STEM. But Gemma 4 simply has no published number. Scoreboard sits at Gemma 4.1, Gemini 3.6 Flash 0, with 1 tied. Test 3, open weight accessibility and local deployment. You build a product on a cloud API, you scale it up, and then you get an unexpected API bill that's way bigger than you planned for, or you hit a licensing restriction that blocks commercial use right before launch. Both of those are real things that happen to real developers. I looked at this one, and it's pretty clear. Gemma 4 is Apache 2.0, fully open weight, and you can run it locally with a single Allama run Gemma 4 command, with 5 size tiers going from a 4.2 gigabytes file on a smartphone all the way up to 69.9 gigabytes VRAM for the 31 billion dense model. Gemini 3.6 Flash is cloud only, no open weights, no local path. That's just a factual difference. Gemma 4 wins test 3, and honestly, it's not close. I was expecting at least some partial local option from Gemini 3.6 Flash, but there's nothing, no weights, no install path, no on-device option at all. So Gemma 4 wins this by default and on merit. It moves the scoreboard to Gemma 4.2, Gemini 3.6 Flash 0, 1 tie. Test 4, context window and long document handling. Run out of context mid-task, and your model starts forgetting earlier parts of the document, which means wrong answers and broken outputs on anything long, like a full code base, a legal contract, or a research paper. And you end up either chunking everything manually or paying for a RAG pipeline you didn't want to build. I looked at the sourced evidence here, and the gap is pretty stark. Gemma 431 billion, 26 billion, and 12 billion all come with a verified 256,000 token context window, confirmed by the vendor model card and the ArcSIF technical report. And the smaller E2B and E4B models get 128,000 tokens, which community testers say fits about 96,000 English words locally. For Gemini 3.6 Flash, there's simply no published context window figure in the evidence I found. Gemma 4 takes test 4. I went in thinking this would be the tightest call, and it turned out to be the easiest one. Gemini 3.6 Flash just has no published context number to compete with. And Gemma 4's P-rope architecture cuts global KD cache by up to 37.5%. So that 256,000 window is cheaper on memory than it sounds. Final scoreboard, Gemma 4.3, Gemini 3.6, Flash 0, 1 tied. So here's where Gemma 4 clearly beats Gemini 3.6 Flash. Apache 2.0 license means zero commercial restrictions, full stop. 5 size tiers let you run on a smartphone at 4.2 gigabytes or a workstation at 69.9 gigabytes VRAM. So you right-size the model instead of overpaying. The 256,000 context window is verified. And on Cerebras, it hits 1,851 tokens per second, which is the fastest published number in this comparison. Now here's where Gemini 3.6 Flash actually has an edge. It scores 63.9% on MLE bench and 49% on Deeps WE, two real-world ML engineering and multi-file coding benchmarks where Gemma 4 has no published equivalent numbers. It uses 17% fewer output tokens than its prior version, which directly cuts API costs at scale for agentic workloads, and enterprise users like Harvey and Hebbia are already running it in production for financial document parsing. Okay, so here's the decision roll. I went in thinking this would be a close fight, and honestly, Gemma 4 dominated most of the documented dimensions, but the right answer still depends on your setup. If you need local deployments, Apache 2.0 commercial freedom, or a large context window without a recurring cloud bill, Gemma 4 is your pick. If you need proven production scale for agentic workflows where token cost is the thing you're optimizing, Gemini 3.6 Flash is probably enough.